In this video, going to go over some linear momentum questions. And the first question has been given a 4 kg ball which is moving east at a speed of 5 meters per second, which strikes a 2 kg ball which is at rest. So the scenario given, we have got a 4 kg ball. It is moving in the east direction at a velocity of 5 meters per second, and it strikes a 2 kg ball which is not moving, which is at rest. So let's call this one as our M1 and this as our M2. So when these hit the 4 kg ball which is moving, the velocity is going to reduce, and so it is going to give some of its velocity to the other ball. Okay, this is a 4 kg ball. The ball which is at rest is going to gain kinetic energy, and so it starts moving at a certain velocity v2. Okay, so now I want to calculate the velocity at which these two are going to be moving. So according to the conservation of momentum initially should be equal to the final momentum. And so what we are saying is m1 u1 plus m2 u2, that should be equal to m1 v1 plus m2 v2. So the first portion is telling us the momentums of the two balls initially, and then the second part, it is the final momentums of the two balls. So m1 is 4, the initial velocity of the 4 kg ball is 5, m2 is 2, the initial velocity was at rest, and so the velocity is 0. That should be equal to m1 is still 4, and then v1 we don't know, m2 is 2, v2 we don't know. So these are the final velocities at which they will be moving, which we don't know. So 4 by 5 gives us 20. Of course, 2 times 0 is still 0. That gives us 4 v1 plus 2 v2. So let's call this as our first equation. Now this scenario is a perfectly elastic collision. So just by that perfect elastic collision, that tells us kinetic energy is conserved. So the kinetic energy of the two balls before collision should be equal to the kinetic energies of the two balls after collision, and that simplifies, gives us the equation u1 plus v1 is equal to u2 plus v2. So this is from the conservation of kinetic energy. So the initial velocity of the first ball was 5. The final velocity of the first ball we don't know. Then the initial velocity of the second ball, it was at rest, 0. The final velocity of the second ball we also don't know. So this gives us 5 plus v1 being equal to v2. So we call this as our second equation, and so we're going to solve these two equations simultaneously. So in the first equation, where we can see v2, we can replace. So we have got 20 is equal to v plus 4v1, and then 20 is equal to 4v1 plus 2. So where there was v2, we are going to substitute here. We know that v2 is equal to 5 plus v1. So that gives us 20 is equal to 4v1 plus 10 plus 2v1. So we just distributed the 2 on those. So if we take the 10 this side, it will be 20 minus 10, it will become negative, and so we're going to have a 10. And then we add the 4v1 plus 2v1, we get 6v1. So want to remain with v1, we divide by 6. So our v1 is going to be 10 over 6, which is 1.67. Okay, 1.67 meters per second. How do we find v2? So we come to this equation. We know that v2 is equal to 5 plus v1. So that is going to be 5 plus 1.67, which will be 6.67 meters per second. So we've seen that this one, which was at rest, has gained kinetic energy and it has started moving at that velocity. The other one, which was moving, the velocity has reduced from 5 to 1.67. All right. A second question given: a 10 kg block moving east at 15 meters per second collides with a 5 kg block at rest. So we have got a first block which has got a mass of 10 kg and it is moving east at a velocity of 15 meters per second. and then it collides with another mass, which is a 5 kg mass, which is at rest. And then after this collision, these two balls stick. Okay. So now they've got a combined mass, let's call it capital M, and then they're going to move at the same velocity, let's call it V. So if we say this is M1 and this is M2, now this kind of scenario is an inelastic collision. Kinetic energy is not conserved if two things stick. And so what we're having is momentum is always conserved for any form of collision. So the momentum before impact should be equal to the momentum after impact. That is M1 U1 plus M2 U2. That should be equal to, now the momentum after impact, these two are together, so they are going to have only one momentum. They are going to move together. So I've got a combined mass, and then they're going to move at the same velocity. M1 is 10, U1, it is moving at 15 meters per second. That's the initial velocity. The second mass is 5. The velocity, it is at rest, so the velocity is 0. And that should be equal to the combined mass, 10 kg plus 5 kg. That will give us 15, and we want to find the velocity at which both of them move. So 10 times 15 is 150. This is still 0, and that should be equal to 15V. So to remain with our V, we divide by 15 on both sides. So our V therefore is going to be 15 into 150 will give us 10 meters per second. So that will be the velocity at which both of them are going to move. Another question, a 15 grams bullet is fired horizontally at 350 meters per second into a 1.2 kg block that hangs by a vertical string. The bullet remains embedded in the block. So what we've been given is, we've got a vertical string where there is a certain mass. And then we've got a bullet which is fired. So this bullet it is fired horizontally, so it is moving straight, though my diagram is not that straight. So it's going to move straight and then hit this block. So the bullet is 15 grams. The block is 1.2 kg. So let me call this one as M1 and then this one as M2. So if this sticks inside, when the bullet hits this block, it's going to move. Okay, it moves, and now the bullet is going to be inside. Okay, the bullet now will be inside the block. It remains embedded, and so now they've got also a combined mass here. Let's call it capital M, and then they're going to move also at the same velocity. So from this point to that point, they're going to move at the same velocity. Now considering where this was, we've got a height here, which it has moved. So let's call it h. Okay. So now our first question, what is the final speed of the block and the bullet? So according to the law of conservation of momentum, the momentum before impact, that is m1 u1 and then plus m2 u2, it should be equal to the momentum after impact. Now these have the bullet is embedded in the block, and so they've got a combined mass capital M, and they are going to move at the same velocity v. So the first mass, we've got 15 grams. The bullet is 15 grams, so we convert it to kilograms by dividing by 1,000. So that is 15 over 1,000. That is 0.015 kg. So that is the first mass, 0.015. And then v1, it was moving at a velocity of 350 meters per second. And then plus the second mass, which is 1.2 kg. It was at rest, so the velocity is 0. And that should be equal to the combined mass. So this is the 0.015 plus the mass of the block, which is 1.2. So 0.015 plus 1.2, that gives us 1.215 v. Okay. So multiplying 0.015 by 350, we get this side 5.25, because this part will give us 0. That is equal to 1.215 v. So I want to remain with v, so we divide by 1.215 v, even the other side 1.215. Sorry, we are not v, just 1.215. I want to remain with v. So therefore what we are going to see is this will cancel. We are going to remain with v here. So the V is going to be equal to 5.25 divided by 1.215. So that is giving us 4.32 meters per second. Okay. Now the other question given, how high will the system rise? So we want to find this height. How high will the system rise? So now what we can see at this point, the block is not moving, so it has got maximum potential energy. Because it's not moving, the kinetic energy is equal to 0. So when it starts moving and it reaches this point, at that point all the potential energy has been converted into kinetic energy. So the kinetic energy is maximum at that point, but the potential energy is now going to be equal to 0. Okay. So what we are saying is, here we've got potential energy, here we've got kinetic energy. So we are losing potential energy into kinetic energy, and then we are gaining kinetic energy from potential energy. So the loss in potential energy is equal to the gain in kinetic energy. So that is what we are going to use. Now potential energy is given by mass times gravity times height. Kinetic energy is given by half mass times velocity squared. Now you can see that we have got masses on both sides, so we can divide by masses. They are going to cancel because we are talking of the same system. So what we are going to remain with is GH is equal to half V squared. So G is 9.8 and then times height, that will be equal to half. Now the velocity is the velocity at which the system is going to move. That is the velocity we found, 4.32. So that is what we are squaring. Okay. So now 4.2 squared, just a moment. Okay. So we are saying 4.2 squared, and then we have divided. So if we square this one, we are going to get 18.67, and then we divide it by 2 or multiply it by half. So we are going to have 9.8h being equal to 9.335. So when we want to remain with our height, we're going to divide by 9.8 on both sides. So therefore our height is going to be 9.335 divided by 9.8. So that gives us a height of 0.953 meters. That is how high it rises on that question. Okay. Another question given, a 15 kg block object moving in the horizontal at 5.5 meters per second collides with a 10 kg object moving in the opposite direction at 4 meters per second. So we've got something, let's say this object, which is 15 kg, is moving in that direction at a velocity of 5.5 meters per second. And then it collides another object which has got a mass of 10 kg, which is moving in the opposite direction at a velocity of 4 meters per second. Okay. So let's call this one as M1. Let's call this as M2. Now we want to find their final velocity if these two objects collide and then they stick. So if they stick now, they are going to have a combined mass. They are going to be together. So we are going to have capital M, their combined mass, and then they are going to move at the same velocity going for. We don't know in which direction they'll go, but obviously they are going to go forward because this one is bigger and then it has got a greater velocity, so it will overcome the other one. Okay, so what we are saying, M1 U1 plus M2 U2 should be equal to mv. So momentum before impact should be equal to momentum after impact. So if they stick, they have got a combined mass and a combined velocity. They are going to move at the same velocity. So m1 is 15. It is moving at 5.5 meters per second. And then plus m2 is 10. It is moving at 4 now. Because it's moving in the opposite direction, we put a negative, so it will be negative 4. And that should be equal to m, the combined mass, 15 plus 10, which is a 25. They want to find v. So 15 by 5.5, and then subtract, or we add 10 times negative 4, which is the same as subtracting 10 times positive 4. Okay, so that is subtracting a 40, because 10 times negative 4 will give us a negative 40. So what we are getting this side is 42.5, 42.5, and that should be equal to 25v. So I want to remain with v, so we divide by 25 over this side and also the other side. So our velocity will be 42.5 divided by 25, which is 1.7 meters per second. So that is the velocity at which they are going to move. So we can see that the velocity is going to reduce for this one. Okay, the velocity is going to reduce. Even for both of them is going to reduce, because if these are same masses and they were moving at the same velocity, if they hit each other, the final velocity would have even been 0. They would have stopped moving. Okay. So the second part is we want to find the velocities if the collision is elastic. So given an elastic collision, for this one, kinetic energy has to be conserved. So in the second part, what we are going to see is they are not going to stick together. Okay. So instead of having them with a combined mass, this one, the m1, which is 15 kg, is going to move at a certain velocity v1, and then the other one is also going to move at a certain velocity v2. So now I want to find those velocities. So first, according to the law of conservation of momentum, momentum before impact should be equal to momentum after impact. So that is m1 u1 plus m2 u2. It should be equal to m1 v1 plus m2 v2. So m1 is 15, v1 is 5.5, and then plus m2 is 10, v2 is -4. It's moving in the opposite direction. That should be equal to m1, which is still 15. We don't know v1. And then plus m2, which is 10. We don't know the velocity at which it will move. Okay. So 15 by 5.5, and then plus 10 times -4. That should give us a 42.5. And that should be equal to 15 v1 plus 10 v2. Okay, so let's call this one as equation 1. So now, because this is a elastic collision, kinetic energy is also conserved. So from the conservation of kinetic energy, we get u1 plus v1 is equal to u2 plus v2. So the initial velocity of the first ball is 5.5 plus the final velocity of the first ball we don't know. The initial velocity of the second ball is -4. It's moving at 4 meters per second in the opposite direction, and the final velocity we don't know. So what we can do is we can take this one that side, so that we are going to have 5.5 plus 4 is equal to, here we are going to remain with v2, and then we take the v1 over that side, so it becomes -v1. So 5.5 added to 4, what we are going to get is 9.5 is equal to v2 minus v1. At this point, I think it would be easier if we just made v2 the subject of the formula, where we take the v1 that side. So what we are going to have is v2 is equal to 9.5. So if this v1 goes over the other side, it becomes positive, so it will be positive v1. This will be our second equation. So in the first equation, where there is v2, we are going to substitute what we can see there. So we have 42.5 is equal to 15 v1 plus 10. Where there was v2, we are going to put that, which is our 9.5 plus v1. So what we are having is 42.5 is equal to 15 v1 plus 10 times 9.5, that is a 95, plus 10 times v1, that is 10 v1. So taking this that side, we are going to get 42.5 subtract 95, that is going to give us -52.5, and that will be equal to 15 v1 plus 10 v1 should be equal to 25 v1. So to remain with v1, we are going to get -52.5 divided by 25. So we are going to get -2.1 meters per second. And then to get our v2 now, we are going to come to this equation. Let's write it there. So v2 is going to be equal to 9.5 plus v1, which will be equal to 9.5 minus, because v1 is negative, so that will be minus 2.1. So 9.5 minus 2.1, we are getting 7.4 meters per second. So what this is telling us is for v2, okay, this v2, when these two balls hit each other, this one which is going like this hits this one, the v2 is going to bounce in this direction. And if we take the x-axis as positive, the other one, the v1, is going to bounce in this direction, so it's going in the negative, and that's why we can see the velocity for v1 is negative. Okay, so that is the problem on that one. Another question given: a 50 kg skater traveling at 4.5 meters per second collides with a 60 kg skater traveling at 2.5 meters per second in the same direction. If the two remain in contact, so they are in contact, in other words they stick, what will be their final velocity? So we have got first, let's say this is the first skater, okay, which is 50 kg, moving in this direction at 4.5 meters per second, and then it collides with another thing which is 60 kg, another skater which is 60 kg, which is also moving in the same direction at 2.5 meters per second. Okay, now if they remain in contact, so if they hit each other, they stick, they are in contact, they've got a combined mass m, so they are going to travel at the same velocity. So if we call this one as a m1, this is our m2. Remember, momentum is always conserved from any form of collision. Because they stick, this is an inelastic collision where you have got some loss in kinetic energy. So what we are saying is m1 u1 plus m2 u2 should be equal to m1 v1. Okay, now for this one, because they've got a combined mass, they are going to also move at the same velocity, so I'm just going to say m and then v, instead of saying m1 v1 plus m2 v2, because the mass will be combined. So m1 here is 50, moving at 4.5 meters per second. M2 is 60, because it's moving in the same direction, it also be positive 2.5, and that should be equal to the combined mass 60 plus 50, that would be 110, and then v, we don't know that velocity, so 50 multiplied by 4.5 and then plus 60 multiplied by 2.5. What we are getting this side is 375, and that is equal to 110 v. So over 110 over 110. So the velocity therefore is going to be 375 divided by 110, which is 3.4 meters per second. Okay, now how much kinetic energy is lost? So the loss in kinetic energy is given by what? So what we are saying is the kinetic energy before impact is not going to be equal to the kinetic energy after impact, but what we need to understand is energy before impact is equal to energy after impact. So energy is never formed nor destroyed, it can only be converted from one form to another. So if at the beginning we had only kinetic energy, at the end we might have kinetic energy, the object will be moving. At the same time, if they hit each other, because they've stuck, maybe they're going to make a lot of noise. Some energy would have been converted maybe into sound or into another form of energy. So energy is not lost nor gained, it's only converted from one form to another. So now what we are saying is kinetic energy before impact is equal to energy before impact, energy before is equal to energy after. Okay, now before, we are going to have the kinetic energy of this object, also the kinetic energy of this object. So what we are having is half m v squared plus half mv squared. So this is m1, so let's call this one m1 v squared, and then this is m2, so we call it half m2 v squared, and that should be equal to Now the kinetic energy after impact, because these balls stack, we are going to say half. They've got a combined mass, and then they are moving at the same velocity squared, and then plus we have got that loss, which we don't know, maybe it was converted into sound energy or into another form of energy. Okay, so initially the first ball is half, the first mass is 50, and then initially it was moving at what velocity? It was at 4.5 meters per second, so we are squaring that, and then plus half. The second ball, the mass was 60, and then it was moving initially at what velocity? 2.5 squared, and that should be equal to half. The combined mass is 110, and both of them we are moving at what velocity? That is the velocity of 3.4 squared, and then plus the loss, which we don't know. So if we work out this portion, we are saying half multiplied by 50 multiplied by 4.5 squared, we get 506.25. And then we work out this part, half multiplied by 60 multiplied by 2.5 squared, we get 187.5, and that should be equal to, we work out this portion, half multiplied by 110 and also multiplied by 3.4 squared, we are getting 635.8, and then plus the loss in kinetic energy. Okay, so if we add this portion which is here, and then we bring to subtract this one, which is which one here, so what we are adding is 506.25 plus 187.5, and then if we take this one this side, it becomes minus, so it will be minus 635.8. so what I'm getting this side is 57.95, and that is equal to the loss. Therefore the loss in kinetic energy is equal to 57.95 joules. Okay, because we are losing energies in joules. Alright, so that will be the answer for that question. Another question given, a 5 kg ball moving at 6 meters per second east strikes a 3 kg ball at rest. The first ball bounces at an angle of 30 degrees below, while the second ball bounces at 60 degrees above the line of contact. So you've got this ball which is moving, okay, it has got a mass of 5 kg, and then it is moving in that direction at 6 meters per second. It strikes another ball which has got a mass of 3 kg. So this is what we are calling the line of contact. So now the first ball, which is the 5 kg ball, bounced at 30 degrees below. So it goes like that. So this is the 5 kg ball at 30 degrees below the line of symmetry, and then the second ball bounced at 60 degrees above. So this one is going to go above, so it is going to be there. That is a 3 kg ball, 60 degrees. Okay, now I want to calculate the velocities of the two balls. What will be the velocity of the first ball and the velocity of the second ball at the end? So we are talking of now, let's call this as V1, and then this as V2. Let me even show it here, V2. Okay, now what we need to get to understand is for this V1, this velocity which is making this to move like that, it has got components. It has got the x component in that way, so that is the V1x, and then it has got the y component in that way, so that is the V1y. And then same with the V2 also, it has got the x component in that way, so that is the V2x, and then it has got the y component in that way, that is the V2y. Okay, now we are going to work with motion in the x and also in the y. So starting with motion in the x, so x components. So talking about x components, momentum before impact should be equal to momentum after impact. So that is m1 u1 plus m2 u2, it should be equal to m1 v1x plus m2 v2x. Now for this one, I've just written m1 v1. That is because it was just moving in the horizontal. It is moving on east. The other one is not even moving. Okay, so m1, the first mass, let's call this as m1 and then this as m2. So m1 is 5. It was moving at 6 meters per second. And then m2 is 3. It was moving, it wasn't moving, it was at rest, so it is 0. And that should be equal to m1, which is what? 5. Now v1, how do we find the velocity in the x? Now considering this angle which you've been given, okay, we are talking first of the first ball. m1 is this one, which is here, the 5 kg ball. Because the 5 kg ball, that's what we called m1. So the velocity in the x, this is the velocity in the x. As we can see, the angle which you've been given is adjacent to that side, and so we are using cos. So to find v1x, v1x is v cos theta. Okay, now this v we are talking about is the v1, which is this one, v1 cos theta, the final velocity, because the final velocity will be broken into components. And so what we are going to say is we are going to substitute where there's v1x, we are going to put v1 cos. Now we are talking of the theta, so this one bounced going downwards, so the angle theta there is negative 30 because it went down. If you consider the x or y plane, if you take angles which are going in the clockwise direction, we take them as negative angles. Otherwise, we measure angles going in the anti-clockwise direction. Okay, and then that will be added to m2. m2 is still 3 kg. And then how do you find v2x? So v2x is also v2 cos theta. Now for this one, the theta is skisty and it is going up, so it will be positive. So that will be v2 cos skisty. Okay, so 5 by 6 is a 30. Of course, this will give us a 0, and that will be equal to cos negative 30 is 0.866. Okay, that is giving us 0.866, and then that 0.866 multiplied by a 5. Remember, we also have a v which you don't need to forget there. So times 5, so that is 4.33 v1. So we don't forget the v1 there. And then plus, so if we press cos 60 is 0.5, and then 0.5 multiplied by a 3 outside there, it's 1.5. So that is 1.5, and then v2, which is there. So this is the first equation which we have. That is in the x component. Now we also go to work in the y component. Okay. So in the y component, same momentum is conserved. m1 u1 plus m2 u2 should be equal to m1 v1 y plus m2 v2 y. Now this ball is not moving in the y, it is only moving east, that is in the horizontal, and so motion in the y is 0. So the velocity in the y is 0. It is not moving up, it's not moving down, that's why it is 0. And then the second ball is also at rest, it was also 0. So m1 is going to give us 5 kg. Okay, and then v1y, how do we find this velocity in the y? Now considering this velocity, it is opposite to the angle, so we are going to use sine. So v1y is going to be v1 sine theta. So we are going to say 5, where there was v1y, we are going to put v1 sine. Now the theta is negative 30 for the first one. Okay, and then plus m2, which is the 3 kg object, and then v2y will also be v2 sine, but here the angle is positive 60 because it's going up. So what you are going to have is 0 is equal to sine negative 60, sine negative 30 is negative 0.5, and then multiplied by the 5 which is outside, that will give us negative 2.5, v1, and then plus sine 60, which is 0.866 multiplied by 3, which is outside. That is going to give us a 2.598, and then v2. So this will be our second equation. Okay. Now we need to solve these two equations simultaneously. So what I can do, I can take that side, so it becomes positive 2.5 v1 is equal to 2.598 v2. I divide by 2.5, also that side by 2.5. So what our v1 is equal to 2.598 divided by 2.5. I'm getting about 1.039 v2. So in this equation where there is v1, I'm going to replace with that portion. So what I'm having is, okay, now I can clean up space. So what we have from this equation, which is here, is we have 30 is equal to 4.33. Where there was v1, then I substitute that one, which is 1.039 v2, and then plus we have got 1.5 v2. Okay, at this point now, let me remove. Okay, that one I think would be important instead of removing it. Let me keep it there. I can remove this portion. So what I'm having is 30 is equal to 4.33 multiplied by 1.039. So that is giving 4.4998 v2, and then plus 1.5 v2. So if I add, these are like terms because they all contain v2 in them, so we can add them. So what we are going to have is 30 is equal to 4.49 plus 1.5. So that is going to give us 5.99987 v2. So for us to remain with v2, we are going to divide by 5.99987 on both sides. So therefore our v2 is going to be 30 divided by that 30 divided by 5.999. So that is going to give us 5 meters per second. What of v1? What will be the answer? So v1 is 1.039 multiplied by v2, which is 5. Okay. So v1 therefore is going to be 5 multiplied by 1.039, which is not so different, is 5.195 meters per second. So those are the two velocities for the two balls after impact. Okay. Another question we've been given: a 25 grams bullet which is moving at 230 meters per second penetrates a 2 kg block of wood and emerges cleanly at 170 meters per second. If the block is stationary on a frictionless surface when hit, how fast does it move when the bullet emerges? So we've got a bullet which is moving. So this is a 23 grams bullet. Let me call it as the M1. And then it is moving at 230 meters per second. Okay, and then it hits a block. And then after hitting this block, this passes, the bullet is going to pass and then emerge cleanly. It comes out from here. Now the velocity has been reduced. It's now moving at 170 meters per second. So this is 2 kg. Okay. Now I want to find because when the bullet comes out, this block is also going to be moving. So I want to find, let's call that one as our V2. Let's call it V2. Okay. So if this is our M1, then this will be our M2, the block. So momentum before impact, that is M1 U1, that is looking like V. Let me write it. M1 U1 plus M2 U2. It should be equal to the momentum after impact, that is M1 V1 now plus M2 V2. So V is representing final, U is representing initial. M1, the mass of the bullet is 23 grams, so that is 23 divided by 1000 to convert it to kg. So 23 over 1000, that gives us 0.023 is now in kgs. Okay, so that will be 0.023 multiplied by the initial velocity, which is at 230, and then plus m2, which is 2 kg. Now it wasn't moving, it is at rest, so the initial velocity is 0. That should be equal to m1 is still 0.023, but the velocity at which it is now moving is 170 after passing through the mass. And then plus m2, which is 2 kg, want to find the velocity at which it will be moving. So 0.023 multiplied by 230, that is going to give us 5.29, and that is equal to 0.023 multiplied by 170, that is giving us 3.91, and then plus 2v2. So if we take this one that side, it will be 5.29 minus 3.91. So that is 5.29 minus 3.91. We are going to get 1.38 is equal to 2v2. So to remain with v2, we divide by 2 both sides. Therefore, our v2 is going to be 1.38 divided by 2, which is 0.69 meters per second. So that is the velocity at which it will be moving after the bullet emerges. Okay, that now marks the questions. Hope it was helpful. If that was helpful, you are going to do well to subscribe to our YouTube channel. Thank you so much for having watched the video. Have a blessed day.